Good morning. Let us see about the classification of oscillators. Based on the output waveform, there can be sinusoidal oscillator. Sinusoidal oscillators purely generate sinusoidal waveforms. Non-sinusoidal oscillators generate output waveforms such as triangular waveform, square, sawtooth, and so on. Based on the circuit components, it can be classified as RC oscillators, LC oscillators, crystal oscillators. What are RC oscillators? So if the feedback or if the circuit consists of resistors and capacitors, then it is called RC oscillators. If the circuit components consist of inductors and capacitors, then it is called LC oscillator. So if it has a crystal, then it is a crystal oscillator. Another classification is based on the range of operating frequency. If it is in the audio frequency range, that is from 20 Hz to 100 to 200 kHz, or it can be a high frequency or radio frequency oscillators more than 200 to 300 kHz up to gigahertz. Based on whether feedback is used or not. Feedback type of oscillators, that is, if the oscillator is used as a feedback, or non-feedback oscillators, if the oscillator which does not use a feedback. So these are the different classifications of oscillator. Let us see LC oscillators in detail. So LC oscillators. There are many types of LC oscillators. Hartley oscillator, Colpitts oscillator, Clap oscillator. Let us see about Hartley oscillator in detail. So this is the circuit of Hartley oscillator. So we have a transistor, radio frequency coil, R1, R2, which acts as a voltage divider bias, and we have a tank circuit. So the tank circuit comprises of two inductors and one capacitor. So this tank circuit has only L and C components, and hence this is a type of LC oscillator. So here this transistor will produce an 180-degree phase shift, and this tank circuit will produce 180-degree phase shift. Thereby 360-degree phase shift occurs in a loop which satisfies Barkhasan criterion for oscillation. So hence the criterion for oscillator is satisfied. So let us see the circuit description. R1, R2 will provide the voltage divider bias. RECE provides bypass network. RFC, that is a radio frequency coil, is used to isolate the oscillator output. And we have coupling capacitors. We have two coupling capacitors. First coupling capacitor is used to couple the signal between the feedback and the input to the transistor. And here you have the second coupling capacitor, which is used to couple the output of the transistor to the input of feedback. So we have two coupling capacitors. And we have the tank circuit has two inductor and one capacitor. So moving on to the working principle. So the input is applied to the base terminal of the transistor, which produces 180-degree phase shift. So the input, the transistor will produce 180-degree phase shift, and the feedback network will provide 180-degree phase shift. Totally we have 360-degree. Hence, the condition for the oscillation is satisfied. Now let us see the circuit analysis. Consider the equivalent circuit. Consider the resistance as Ri. and consider the output inductor L2. So let me take output voltage Vx and it has a component Zx. The characteristic impedance Zx can be calculated as, so here R1, Ri and the inductor, they are connected in parallel. So if two components are connected in parallel, so then we can write Ri into j omega L2 divided by Ri plus j omega L2. So considering this input equivalent circuit, we have input side we have L1 and one capacitor. So by the Ohm's law, we know that V is equal to I into R. Here we have impedance, so Ix into Zx. So input Vi, let me consider it as Vx. So consider Vx as Vi is equal to Ix into Zx. By using the current divider rule, the total current is minus Gm into Vi. So the current can be written as total current into opposite side resistance. So opposite side resistance is the inductor L1 divided by the total resistance, the inductor, capacitor and Zx. Substitute the value of Ix in equation number 4. Divide by Vi. So here Vi will be getting cancelled and hence we get equation number 7. Now we know that from equation 1, what is Zx, the characteristic impedance? J omega RIL2 divided by Ri plus j omega L2. So substitute that value and we get equation number 8. To find the condition of oscillation, consider only the imaginary part. So first write down the terms, imaginary terms, j omega RIL1 minus j Ri by omega c plus j omega RIL2 equal to 0. Cancelling j terms, take Ri common, left side take j omega Ris common. Ri has been getting cancelled, omega square we get 1 by c into L1 plus L2. So let me consider if the inductors are connected in series, then what is L equivalent? L equivalent is L1 plus L2. So consider it as L equivalent. What is omega? Omega is equal to 2 pi f. 2 pi f the whole square is equal to 1 by c into L equivalent. So f is equal to 1 by 2 pi root L equivalent into c. Condition for sustained oscillation. So here we make real part is equal to 0. So what is the real part? So we have minus omega square L1 L2, L2 by c, and here we have minus Gm omega square L1 L2 into Ri. So consider only the real part. L2 by c, move it to the right hand side. The negative signs get cancelled. Take omega square L1 L2 common. Cancelling L2 and we get 1 plus Gm into Ri is equal to L1 plus L2 by L1. So L1 by L1 is 1 plus L2 by L1. So this is the condition for sustained oscillation. Similarly, we have Colpitz's oscillator. So in the Colpitz's oscillator, instead of using two inductors, here we use two capacitors and one inductor. So similarly, other circuit is same. So we have coupling capacitors, we have R1, R2 to provide the voltage divider biasing, we have the bypass network, and the tuned circuit has the components C and L. Hence, it is also an LC oscillator. So coming to the working principle, the transistor will provide 180-degree phase shift. The feedback network provides 180-degree phase shift. Totally we have 360-degree. Hence the condition for oscillation is satisfied. So coming to the circuit analysis, consider Ri and the output capacitance C2. Here we are able to calculate the impedance, the characteristic impedance ZX, Ri into 1 by j omega C2 divided by Ri plus 1 by j omega C2. First we have to calculate the value of ZX. From the input equivalent circuit we have another one C1, we have one L. So by using Ohm's law, Vx is equal to I into Zx. Consider Vx as Vi and substitute the value of Ix in the equation 5 by using current divider rule. We have to find the value of Vi. So Vi has been getting cancelled. We get an equation with real and imaginary terms in equation 8. Substituting the value of Zx, we get an equation 9. To find the condition of oscillation, take only the imaginary part to 0. Here, when the capacitors are connected in series, then capacitor value we need to take 1 by C1 plus 1 by C2 is equal to 1 by C equivalent. So my C equivalent will be C1 C2 by C1 plus C2. Omega is equal to 2 pi f. F is equal to 1 by 2 pi root L into C equivalent. For sustained oscillations, consider only the real part to 0. So considering only the real part, Gm into Ri is equal to C1 by C2. So this is the Colpitz's oscillator. Thank you.